Recording.
Hello everyone, I'm here. We are in the practice session, just waiting for everyone else to join in. So I'm very much here. Mr. Shubhro, I'm here. Good evening, everyone. Good evening, Shri Prada ma'am. Good evening. So I think as we are waiting for everyone to join, thank you so much to all the faculty members who have joined the session today. Uh, it is day two. Yeah, Ms. Shriprada, there is no coupon code this time. So we have made the process very simple for you. You just have to go on Future Skills Prime, fill the onboarding form. You will see the group. You will see your group. I will just show it. Just give me a minute. I'll share my screen. I'll show you how to access the course, the assessment. So I'm just sharing my screen. So this is the Future Skills Prime website. You just have to go here. You log in. We have created your group. So you fill the onboarding form. I have already filled it. Now you go in groups. Okay. So when you go in groups, there is this, you'll see this group AICTE Atal Online FDP Generative AI Fluency. So you visit this group. Okay. So this is your group. Generative AI Fluency participants. This is your group. You just go here. This is the course, and where it is written assessment, this is the assessment that you have to take, and you can only take it once. And you need 70% marks to get the Atal certificate. In the previous batches, some of the people have got 50, 60, so they are not eligible for Atal certificate. And you can take it only once. I hope this is clear for everyone. This is the course. Generative AI fluency, get started. Please finish this course also. It will help you in your assessment if you want. But we are covering everything in the lectures. So if you're attending the lectures, you probably don't need to complete the course. But otherwise, please complete the course and then take this assessment over here. This needs to be filled every day. What needs to be filled every day? No, you just have to attend the Zoom lectures. Then we will take your attendance there only. You just have to complete this course and then take this assessment. That's about it. I'm stopping the share now. I hope it's clear for everyone, the course as well as the assessment. So I'm very happy now to welcome our trainer for the first lecture of the day, Dr. Pramod Dasan. He's joining us from Prague, from Czech Republic. And we are really privileged to have him with us here today. I'll request him to switch on his camera. And hello, Dr. Pramod. How are you?
Yeah, hi. Thanks, Kamna. Good, thanks. Except very snowy, wild weather here.
Okay, it's snowing.
Yeah, it's been snowing from last week. So, yeah.
So are you home or are you in the office?
No, I'm home.
Okay, okay. So uh, great to have you with us. And just to introduce, Dr. Pramod Dasan is Director AI with DHL IT Services. He is leading the AI innovations so that customer experience is, made better. And that is his passion also, working to solve complex problems and create problems so that customers have a better experience when they are using the products of DHL ID services. So I'll hand it over to you. There are a couple of questions. You can take the assessment after you complete the course. Otherwise, by Saturday, please complete the assessment so that we can get your scores and update the scores on Atal. So please take the assessment by Saturday. Thank you. Over to you, Dr. Pramod.
Yeah, thanks. Yeah, welcome all. Just 1 second. Yeah, let me bring up the presentation deck.
Dr. Pramod, I'll request you to share the deck with me after the session so that I can share it with all the participants.
Sure, no problem. I'll do that right away. Hope you can see my screen.
Yes.
Okay, great. So, welcome to the Generative AI and Robotics session. So, the agenda for the next 90 minutes would be 4 topics to cover in the order of rise of Gen AI in robotics, introducing Gen AI, what is it about, and then how Gen AI integration with robotics works, and then what are the applications of AI in robotics. So that's the agenda for the next 90 minutes. Uh, so we will cover. the topic. And in the final, we have a Q&A. So it'll be a mix of videos as well as the deck. We'll go through the deck and I'll try to answer your questions towards the end of the session. So in case if you have any questions, you can go to the Q&A part, type in your questions. I'll pick it up during the end of every session. I'll check the Q&A. If there is any question, I'll answer it and I'll go to the next topic. So that's how we will go through for the next 90 minutes. So let's start off with uh, why are we doing this topic? So so I'll start off with why. So AI is being like we had dot-com boom, industrial revolution. So right now it's a time for AI boom. So the reason why we should learn AI is what happens if you're not AI. If you are an AI illiterate, what will happen is the person who's having AI literacy will be replacing you in your job because he would be efficient. He would be a smart worker, not a hard worker. He'll be able to deliver what is required out. So the productivity increases. So the statement which I go is AI won't replace humans, but humans using AI will replace the person who doesn't use or who's an AI illiterate. So with that, we'll start off with the session. So the first module is the rise of AI robots. So let me ask a first question. You can type in the answer in the chat window. So the word robo, do you know from which country did it originate from, or which language did it originate from? So you can type the country name uh, and then let me know. So I'll monitor the chat window here. So is it Japan? Is it USA? Is it Middle East? Israel? Okay, let me increase my volume. I just checked my volume. It is at max. Can you hear me well? Not audible. Okay, just give me a second.
As sir was saying that it's probably snowing there, so maybe there's some network thing. Some of you are again asking me about the assessment. I'll just take, while sir is joining, I'll just explain again. So I'm just taking this to show you how to take the assessment. Miss Vijay Lakshmi has asked how to access the assessment. Hi Pramod. Just give me a minute. I'm showing them how to access the assessment. Just I'll take this thing again. Okay, I'm sharing my screen. So when you log into Future Skills Prime, you will see this is your group. Okay. Go to groups. You will see AICT Atal Online FDP Generative AI Fluency participants. There are 849 participants in this group. This is your course and this is your assessment. Kindly take this assessment, which is written in bold letters over here, assessment. So you need to take this. Miss Vijay Lakshmi, I hope this is clear. Stop sharing. You have to log in. You, Miss Vijay Lakshmi, you have got a welcome email from Future Skills Prime. You have to create your account and then access it. Thank you. Over to you.
Yeah. Can you hear me now? Well, is it better? Okay.
I think wait for the participants. Yeah.
Yeah. Okay. Thanks. So the answer is correct. I think some of you have given the right answer. It's Czechoslovakia, which is perfect. Right now it's called Czech Republic. So the word robo came from the word Czech. Uh, it was in 1920s, back in the days, where it was from the language is Czech, and it came from the play where they use the word called robota, which is a forced labor. So with that, so the word originated from Czech Republic, and with that, we will start off with introduction. So with the overview of Gen AI, so it can be classified into two items. The first item is I use Gen AI as generative AI, so I've used a shorthand called Gen AI. So the Gen AI is used in robotic design and prototyping, so that the time to market is reduced, and it can be well trained through various algorithms, which we will talk. So that's the second point. There's something called Gen augmentation, which will help for the robot to train on various environments so that it can work seamlessly. So these are the two top areas where Gen AI is used in the robotic design. So let's look at how big is the market insight. So the first and the foremost thing is, if you can see here on the left hand side, the Gen AI robotic market itself is growing exponentially. So the data is from 2022 all the way to 2032. So the current market in 2022 is started off with 15 million US dollars, and the robotic market is projected at the rate of 856 million by 2032. So which is basically at a 34% of a compound annual growth rate. The robotic market is growing higher and higher. So the highlights is the significant industrial developments and with the technology. So the lot of the Gen AI is coming into the human interaction, and it comes into the interaction. We had industrial robots, and now we have from industrial robots to the domestic robots are being developed at this point in time. So that's how the market is picking up. So let's start off with a small video on the Gen AI and how it interacts. So let me share a video clip and let's understand. Yeah, that's the first video. How the robot name is called Locus, and it is used for the pickers and packers. It's a 12-minute video where it gives an extensive view of how Boston Dynamics is partnering with DHL that in that video that I've shared. So this is just a snapshot of how robotics is automating the warehouse domain. So the Locus Robo is used for the pickers and packers to help and navigate in a warehouse path to do the job efficiently as a picker and packer. So let's look at from a market player perspective, who are the major companies which are working with GenAI slash robotics. So some of the major companies includes OpenAI. I think everybody's using ChatGPT, so it's from OpenAI. Then we have Boston Dynamics, we have NVIDIA and Siemens. These are all some of the major companies which work with GenAI or contribute to GenAI slash robotics. In the next video, we will see something called digital twin and how BMW is using digital twin for, and the digital twin is named as Omniverse, and how robotics and the digital twin is used for modeling a BMW production line. So we'll watch this. Then let's look at market segmentation. In the market segmentation place, so we have hardware, software, and service. So that's the product breakdown of a robo. So a robotic consists of a software, hardware, and services part, and it also based upon the technology or the application where it is used. So in terms of the first part of it, so what you've seen is how robotics are used in a various high level part and what are the components or the product breakdown structure of a robo. And then the second part is some of the companies which is using like DHL, BMW, and how NVIDIA is using it. That's what we have covered in the first part. In the second part of the agenda, so if there are any questions, you can type it in the Q&A session or in the chat window. So best is the Q&A part. I'll monitor the Q&A part. If there's any question on the first part, let me know. So looks like there's no question. I'll jump to the second part. In the second part of introducing to the Gen AI, so let's start with what Gen AI means and what is actually is doing, and then some of the technologies under Gen AI and how actually the Gen AI works. So let's try to understand that. So the first thing is generative AI is nothing but a trained neural network. If you're from electronics and communication background, there's a neural networks which we have studied. What it basically does is it generates new contents based upon an input using a data, right? It can be a prompt, for example, draw a cat with the sunglasses, which you will see subsequently in the video. So that's a parser, and you can see how the Gen AI will generate an image, right? So, for example, what technologies are using this Gen AI is, for example, most of you are using ChatGPT. From India, we talk about Perplexity and the Common Browser, which is a search engine, which is also using it. It is revolutionizing how the Gen AI is working on the search engine part. Dale, for example. So, and then you have other products which is there like DeepSeek, for example. So these are all using the Gen AI technologies. And let's start off with how Gen AI works in the small video.
The audio is not audible. You have to share with sound.
Okay, so let me reshare it.
Yeah.
And create something from a graphic designer working on a new project. One day, her colleague mentions a tool that helps create designs, images, and text using AI. Intrigued, Emma wonders how AI can create something from scratch. Her curiosity grows, and she decides to dive deeper into this new technology called Generative AI. Generative AI refers to a type of artificial intelligence designed to create new content, such as text, images, music, and videos. Unlike traditional AI, which analyzes or categorizes data, generative AI produces original content based on patterns learned from vast datasets. Essentially, it generates new, unique material. These models are often trained on large amounts of data and use sophisticated algorithms to mimic human creativity. Tools like ChatGPT or DALL-E can create art, write essays, or simulate conversations by generating outputs based on user prompts. Generative AI has a wide range of applications. Content creation. Tools like GPT-4 generate text, blog posts, stories, and essays from simple prompts. Art and design. AI models such as DALL-E generates unique images and designs based on text descriptions, transforming creativity in art. Music and audio. AI can compose music or replicate voices, offering new possibilities for musicians and audio engineers. Healthcare. Generative AI simulates disease progression or creates synthetic medical data, helping doctors gain faster insights for research. Let's take image generation as an example to explain how generative AI works. Data collection and learning. AI models like DALL-E are trained on large datasets of images paired with text descriptions. These datasets teach the model to recognize different objects, colors, styles, and how to associate text with corresponding images. The more data the AI learns from, the better it can generate accurate and diverse images based on user prompts. Neural networks and transformers. When Emma inputs a prompt like a cat wearing sunglasses, the transformer model processes the text, recognizing words like cat and sunglasses, and links them to images it learned from during training. Transformers help the AI decide how to combine these elements into a coherent image. Tokens and context. The text input, such as a cat wearing sunglasses, is split into smaller parts called tokens. The AI processes each token and understands their relationship. For instance, it knows the sunglasses should be placed on the cat, creating a contextually accurate image. Feedback mechanism. Generative AI models improve through feedback. After generating an image, users provide feedback on the accuracy or quality of the output. If Emma's generated image shows the sunglasses floating beside the cat, she can mark it as incorrect. The model uses this feedback to improve future image generations. Reinforcement learning. Reinforcement learning further enhances the AI's ability. The model is rewarded when it generates accurate images and corrected when it makes mistakes. For example, when Emma describes a sunset and the AI produces a vibrant sunset image, it receives positive reinforcement. Over time, this method refines the model's ability to generate better images. Data science and AI models. Data scientists curate the training data and define the parameters that help the AI generate accurate images. The more varied the dataset, the more versatile the AI becomes in generating diverse types of content. Advanced models use billions of parameters, which are settings that guide the AI in processing data and generating outputs. Generating original content. Once trained, the model can generate original images. For example, Emma might describe a futuristic cityscape, and the AI would produce a unique image based on what it learned. The generated image isn't just a copy of past data, but an entirely new creation, showcasing the AI's ability to combine learned patterns and creativity. Now let's have a quick fun quiz on what we have learned so far. What does generative AI primarily do? A. Analyze data. B. Generate new content. C. Store data. Make sure to let us know your
Okay. Let's end the video with this answering this question. So what does the generative AI primarily do? Okay, thanks, Kitika. Thanks, Suganti. Thanks, Aranya. So I'll just wait for a few more seconds and then, yeah, thanks, Tushar. Yeah, I think most of you got it right. Generative AI primarily generate the new content. Yes, I think this is the first batch which answered it correctly because a lot of people said A, B, and C, sometimes B, and sometimes A. I think this group has got it correct. So primarily generates new content, but it also uses of store data, analyze data in order to generate a new content. Right. Okay. So now let's see what is the impact of employment. So people call this as an AI boom because if we look at Gartner researchers and other research in AI or agentic AI, so they say that because of generative AI, that poses a lot of risk in replacing the jobs. Actually, especially in the area of content generation, like blog writing, content, contract creation, and coding. Uh, there is a slight impact. However, it increases efficiency. It depends upon how do you see things. But also, right now, what the bigger companies are seeing is the cost of investment for Gen AI technology is so huge. The ROI, the return on investment for the generative AI is not as expected as what was invested. So there is always a debate on how it is being used. So we are in a phase of AI boom where it can burst, and uh, eventually people will be using the AI or Gen AI technology rightly in the near future. So that's one of the Gartner research also talks about it. Now let's look at one of my interesting video. Let's look at how AI robo is used in the kitchen. So how you can see the robots are used in the commercial domain or industrial space like DHL warehouses, BMW. Now let's look at uh, a roadside shop or a food court in a corner shop, how robotic kitchen automating the experience of the food industry in this video.
As robotics obsessed engineers, we set out to create a new, efficient way of cooking food. Our woks cook by constantly tumbling your food, which provides a really nice and even sear. They're heated with induction, and we have temperature control to perfectly cook your meal every time.
From our humble starts in our fraternity basement, we developed a prototype that really sort of proved we could build something that can create delicious, high-quality meals.
I needed to come to Boston. I discovered that the robotic kitchen bring precision, consistency, taste, and also freshness to the preparation.
Yeah. So that's a preview of the robotics. Just imagine um, how this is going to revolutionize the the food industry. Um, for example, the moment when you order food, let's say Swiggy or Zomato, they go and pick it up from a local restaurant. Assuming if you have a warehouse built by Zomato or Swiggy with this kind of robot, and if you want to have a Michelin taste food, the robot can cook and then start delivering from the cloud kitchen concept. So again, this is one of the revolutionizing part of it. So this is not commercially available yet massively, but This is something that is available only in Boston at this point in time. So hope we see this in the near future. So this is an example of how the technology advancement happens in a domestic robo for cooking. So let's look at the success, the generative AI in robotics. Let's look at what generative augmentation means and how this is enhancing the robotic capabilities to train and reduce the time to market. So let's look at with a small example before I switch on the video. So for in order for a self-driving cars, before the technology advancement of generative augmentation, and GenAI. So typically, they run a typical car test drive is run on the various roads, on the test circuits. It collects the data, and then you are developing a self-learning, self-driving software, right? And you need to spend lot of hours to understand the various landscapes, various distractions, what in order to develop the self-driving cars. But the use of gen augmentation, we will see in the upcoming video how this accelerates the data generation and the training of robo very quickly, so the time to market is reduced. So let's understand what GenAug means and how it is used.
In this work, we present GenAug, retargeting behaviors to unseen situations via generative augmentation. Current robot imitation learning systems often require humans to provide demonstrations. While this method may succeed in environments that are similar to the training set, they often fail in environments that are far from training distribution. Our system GenAug closes this gap by automatically generating a large and diverse set of training data.
Just to put a context in place, so basically, this robo is to going to pick up this mouse and put it onto the basket, right? So now with generative augmentation, how you can change the layout, because this is a table, and now you can see on the right hand side unseen environments, unseen objects. So how the robot arm can change to pick up any objects in any environment and generate the data for the training is what we will see in the gen augmentation.
Using text-to-image generative models. Given a demonstration on one simple environment, GenAug can automatically change the texture of the objects in the scene, change the object classes, change the table and background appearance, and add distractor objects. So starting from the initial single environments, we can automatically generate a much larger and more diverse dataset. Here we show more visualizations. We use a 6-DoF XMR robot with a vacuum gripper mounted on the large table with an Intel RealSense camera mounted on the tripod. Given a few demonstrations of a behavior in a simple environment and the associated text prompt, our goal is to transfer this behavior to any unknown scenes. To do this, a user generates a small dataset by specifying pick and place locations. These 2D locations are projected to the 3D points in the robot coordinates using calibrated depth maps. We then apply GenAug to create a large and diverse dataset and train a language-guided imitation learning model. Here we show our real-world experiments. By training on the dataset extrapolated from only 10 demonstrations in the simple environment on the left, the robot is able to solve the task in entirely different environments on the right. Here we show another example with a new training object pair. Note that the demonstrations were collected in a relatively simpler scene. The right shows zero-shot transfer to complex scenes with dense clutter. Our system can also generalize to unseen object categories. This implies that agents with behaviors demonstrated with one set of objects can now transfer to other unseen compatible objects. Here we show more real-world results.
So I think there's a question. So basically, this video summarizes how a robot training is done through GenAI. One is picking different objects and in a different environment. I think there was a question, why does or why do you need argument dataset? Is that the question? Or maybe if you can retype the question. So if you are planning to put a robo in a industry, you can work. It's very clear that the environment is controlled. You can work. Let's say if I make a chef humanoid, and if I need to deploy in my kitchen layout is different, while another person's kitchen layout will be completely different. So I have to train my robo on different data sets, and it's an adaptive learning. So what happens is we are using the Gen org to train the kitchen humanoid robo or the chef robo to work on different environments in a different layout of the kitchen. So that's what if you take a robotic vacuum, it uses lasers to identify your room landscape, calibrates it, and then starts vacuuming. That's an example. So in order to train the robo, in order to have this lifting and putting things, it requires the data, the robot has to be trained. It has to look at unseen environments. You need to retrain. And in order to retrain, I cannot put the robot to work on, let's say if I develop a robot to work on a European kitchen, if I need to take this robot and put it on an Indian kitchen, it may not work. The layout is different. The cooking pattern is different. And hence we need different argument data set for training, especially in the domestic robotic markets. So let's summarize. What is GenOC? GenOC uses GenAI to improve robotic training through augmented images. It will fast track and reduce the error rate, right? The traditional training methods face limitations because it is unable to adapt to different environments. That's why we use GenOC. So training robots with GenOC, robots are trained through imitation learning, replicating behaviors for demonstration. That what we have seen in an example, picking up an object and placing it in another basket or something else in a different environment. This is based upon image augmentation techniques, where we have seen different objects can be picked up and we can simulate. It can be a mouse, it can be a knife, it can be in a kitchen, for example, it can be a fruit or a vegetable to a basket, it can be anything. It is modeled differently. So let's look at evaluation of GenAI. So the argument dataset is close about for each task we need at least 1000 images for training. The evaluation efficiency is about 85% success in unforeseen environments and 45% and 52% success in a task for unseen objects in place. So that's the current success rate through the GenAug technology. And let's look at this GenAug new model from Meta AI.
Generative AI is a new breed of artificial intelligence that's designed to learn and create new things on its own. It has the ability to produce art, music, and even writing that can mimic human creativity.
So generative AI refers to a type of AI model that automates the creation of content.
Most of AI in the last couple of decades has been about analyzing existing data that includes predicting likelihood of failures in systems, detecting frauds, recommending items for purchase, or goal image search that return similar image. Generative AI is very different as it allows you to create new content. Generative AI models use complex algorithms and deep learning techniques to analyze and learn from large datasets in order to create new and original content. These models are trained on a vast amount of data and then use that knowledge to create new content that is similar to what they have learned. Generally, the content generated by generative AI is very similar to the data that they have been trained on. To bring variety in training data and regenerate targeting behaviors to unseen situations, generative augmentation is generally used. Generative augmentation is a technique in machine learning that involves generating synthetic or artificial data to augment existing training data. This is done to improve the performance of machine learning model by increasing the size and diversity of the training dataset, which can help further improve the accuracy and robustness of the model. Generative augmentation can be achieved through various methods such as generative adversarial networks, variational autoencoders, and other deep learning models that generate new data based on the pattern characteristics of the existing data. By doing this, the generated data can be used to supplement the existing dataset, providing a wide range of examples for the model to learn from. For example, in image classification, generated augmentation can be used to create new images that are similar to the existing images but with variation in lighting, angle, or background. This can help the model to learn to recognize objects under different conditions, leading to better performance when faced with real-world problems. Robot learning methods and generative augmentation are the two important techniques in the field of robotics and machine learning. While they are separate techniques, they can be used together to create more robust and effective robots. We have already learned about generative augmentation. Let's look at robot learning methods and what they are. Robot learning methods involves teaching robots to learn and adapt to new situations and environments using various types of machine learning techniques such as supervised learning, reinforcement learning, and deep learning. These techniques allow robots to learn from their experience, make decisions, and interact with their environment in a more intelligent and autonomous way. In robotics, generative augmentation can be used to create synthetic data that represents new and unseen situations or environments, which can then be used to train deep learning models. This can help robots to learn to adapt to new and unseen situations and environments, making them more effective and versatile in a wider range of tasks. For example, in robot navigation, generative augmentation can be used to create synthetic data that represents new and diverse environments, such as different layouts, obstacles, and lighting conditions. This can help robot learning methods to learn to navigate in a more robust and generalized way, improving their performance in a real-world situation. For robot learning to generalize, we must be able to leverage sources of data or priors beyond.
I'll stop here because this goes back to the previous thing. So the video shows how the four-legged robot, which is capable of carrying, it is currently used in US as well as in China to carry for the frontline soldiers to carry heavy objects, and they are seen in unseen terrains. And if you see that guarded robot is being trained on the boxes and creates distractions. So it just talks about how generative augmentation will help to train the robot to work on a different terrain. for the front end soldiers. So that's in just how GenOrg is used to train robotics. So that's the part of it. So I just wanted to check if there's any questions in the Q&A before we go to the third module. Okay, so looks like no questions. I'll jump to the third module. In this module, we talk about the integration of GenAI and robotics. We slightly introduce something called embodied AI agents or humanoids. What does it mean? I've not integrated because I prepared this deck about a month ago. So recently, Elon Musk has also launched his Tesla humanoid called Optimus. And there's a latest video which has all the things. I will try to integrate it or send you the link. Watch it. It's quite interesting how the Optimus from Tesla Robo is changing. He's been upgraded. So watch that video. I'll type the link. But I will use the old embodied or humanoid robots uh, in this session. So first thing first, Meta is also one of the pioneers in researching and focusing on embodied AI agents. What it means is a standard humanoid robo which can be used in various applications, right? So, for example, it's already you can see there are robots which are used at least in Europe. If you've traveled, you can see robots are used cleaning automatically in large warehouses. Robotics are used for serving. Even in India, I've seen these robots serving to the customers in a restaurant. So these are all some of the humanoids. In Singapore, it is also used for patrolling and for parking, which is also they introduced. There are humanoids also deployed in the busiest airports for helping the passengers as well. So these are some of the examples of humanoids being deployed for everyday customer interactions, right? The current challenges in robotics is the GenAI methods faces limitations in robotic applications. It can be a compute power as well, or what you call its Moravec's paradox, which highlights that the humanoids we cannot replicate the human sensory motor skills and able to do abstract reasoning. So these are the two areas where human beats robots at this point in time. The other part which I've talked about computation power, but you can see NVIDIA and other processor industries, there are changes in quantum computing which can resolve the computational resources. So, for example, Meta, which is the Facebook parent company, which is having Facebook, Instagram, WhatsApp. So, the Meta has built something called Visual Cortex to mimic human visual processing. It helps and aids in robot learning for the fundamental motor skills like picking up an object or depth perception for a 3D. For example, Ego 4D dataset is one of the dataset compiled, which has 3,600 hours for a human performing task. So one task in the GenOrg is 1,000 images. To train one task, it requires 1,000 images and the visual processing through digital image processing techniques. Imagine Ego 4D dataset has 3,670 hours of humans performing tasks, which means that you can relate how big is the image collection and what volume of data needs to be handled to train a robot. For example, that is used in Boston Dynamics. Boston Dynamics is a company which I think Samsung has bought now, and they are heavily investing for industry robots as well as for military government purposes as well for practical applications. So these are some of the robots which are performing industry applications as well as domestic household humanoids which are performing various tasks. So when we talk about data privacy, it's a huge topic. But before that, let me quickly check about the videos. Yeah. So in terms of data privacy, the potential thing in Europe, we have GDPR, we have DPDP in India, and these are all some of the things that we need to consider when we share the data. For example, if we are using domestic data, for example, for cleaning, we are sharing our layout of our household to Amazon, for example, who is deploying the robots for domestic cleaning purposes, while your data is used by Amazon for various initiatives. For example, given a layout, I should be able to see the possibility of what products that I can sell, I can cross sell for you. This is an example how data is used. So this is concerning about data privacy. So we have to be mindful of what data that we are sharing with with whom, so that this can be used for cross-selling purpose, etc. So GDPR is one of the data protection act for personal data for protecting European citizens. Similarly, we have DPDP for Indian citizens. And the business model consideration. So sometimes, for example, if you look Facebook, they work extensively on your photos. So there are apps being developed that if you upload a current image, you will be able to mimic how you look when you are 70-year-old. Or if you do not have a picture from your kinder age, if you upload the picture, it will try to go back in time or forward in time to generate images. But in order to test that data, you're uploading your photos, and sometimes when you use apps like Facebook, Instagram, you are providing, let's say, in your agreement protocol, that they could access your personal images for model training. So similarly, Google is using the smart app feature, the smart feature in the Gmail, for example, for training their AI. So you need to consider business model considerations, and you need to see how you can limit or what information that you want to share with a commercial company. That's why they call data is the next oil. And China is very good in it. So it has protected all his local population. So Google has its own instance of Google within China. So data is not shared to the external world. Um, so Europe has done that. India is still in progress. Um, Hopefully, eventually, this is one of the topics in upcoming years. So this is something that you need to know to understand the data privacy, what are the risks, and how the various business models works with your data. So let's start off with how Boston Dynamics is putting Atlas into work. So and how the humanoid robot is working in a production line. I've already talked about Elon Musk as well on the Optimus robot. There's a nice video which came last week on that. It happened to be a new launch of Optimus version as well.
Boston Dynamics just dropped new videos of its 100% electric Atlas robot. This is the first time the company has shared videos of this version of Atlas doing something like work, and the first time the company has shown it correcting a mistake. We're digging into the details, so let's get into it. When turning around, Atlas's torso and legs turn in different directions. Given the fully autonomous label on this demo, it could be reasonable to assume the robot made the decision to move that way. Whether it did it because it saves time or energy, I can't say. Pop-ups in the video give us a sense of the robot's vision system and how it marks the different bins it's reaching into. About halfway through this demo, one of the engine covers, that's the item Atlas is moving around, appears to snag, causing the robot to react, reposition, and correct its mistake autonomously. We've seen similar demos from other robotics companies. Figure showed its Figure 2 robot picking up and placing auto parts, even appearing to correct some of its mistakes. Tesla's Optimus robot was also recently shown doing various work tasks, first at the company's We Robot event. However, after reports came out that indicated the robots were human-assisted at the event, Tesla dropped a video showing Optimus in a lab setting doing many similar tasks labeled as autonomous. Another video posted by Boston Dynamics on Halloween shows Atlas doing the same task it did in the previous video while wearing a hot dog costume. In this example, someone dressed as a pickle moves the bins, Atlas catches another snag, and is able to react, reposition, and finish the task. This is the first time Boston Dynamics has shown its new electric Atlas in a work setting. The announcement video shows Atlas rising up off the ground and moving around, demonstrating the robot's hypermobility. At the time, Boston Dynamics said it was developing new grippers, or hands, for Atlas. Later, the company appeared to make good on that promise in a YouTube short. In this video, Atlas did some push-ups with what appeared to be grippers styled like
Imagine being
nubs.
able to build.
Now we're seeing Atlas for the first time with finger-like appendages. Based on the movement shown in these new videos, it looks like Boston Dynamics has applied the same principles of hypermobility to them as they have to the rest of the robot. You can see the finger starts on the bottom to help lift the engine cover, then swivels up to pinch and hold the auto part as the robot carries it to its destination. These new videos of Atlas strutting its autonomous stuff come just weeks after Boston Dynamics and Toyota Research Institute, TRI, announced a partnership to develop AI and robotics. TRI has been working toward the development of a large behavior model, similar to a large language model that generates human-like behaviors instead of text. Boston Dynamics will supply the hardware, and TRI will be supplying the AI. TRI has also been hard at work in the field of self-driving and self-drifting cars. Tesla, one of Boston Dynamics' competitors in the humanoid robotic space, has touted the self-driving features of its cars as a helpful foundation for building out the type of AI needed to power humanoid robots. As Boston Dynamics works toward the commercialization of its humanoid robot technology, it's interesting to see the company partnering with an automotive AI company. Things are really heating up in the
Yeah. So I've also shared the Tesla Bot Gen 3, which is Elon Musk has showed this 3 weeks ago in the launch. So basically, how he has all the technology capability to deliver this Optimus Robo. So it's a 19-minute video, so you can watch it later. But that's something interesting to see how the robotic is changing and how humanoids can eventually occupy our space to do certain work for domestic purpose, domestic help, example, right? So with that, we complete our third section, and we will go to the fourth section. So I just want to check if there's any questions. Let me quickly check the Q&A part. No questions. Then the last topic is AI in robotics. What are the applications and innovations in various industry? So in the first three sessions itself, we have seen what are the various applications in logistics, in manufacturing, in car production line. We will see furthermore in the upcoming session. So in this section, what we will be looking at is AI robotics in various fields. So just to give the number, the robot industry evolved significantly since 1960s because of the various breakthrough in technologies and a lot of investment going in as well. So nearly 3 million industrial robots are currently enhancing various sectors. So we have already seen the dark factories in China, which means that it is completely zero touch by humans, completely end-to-end designed and maintained by the robots for delivering industrial manufacturing hubs from China, for example. Let's look at some of the various industries where AI, where robotics is used. So AI aims to create intelligent environments for better automation. So we have seen through GenAI, GenAI, how it is used for training and bringing the robots into the market quickly. Also, it utilizes the computer vision, intelligence programming, and reinforcement learning to make it in a high successful to be successful in delivering a capability as well. We also seen the market growth. It's an exponential growth of 34% year on year as well. Some of the key use cases are listed below. So we'll go through step by step. So agriculture, manufacturing, health, transport, smart home application, aerospace are some of the key use cases where AI robotics is used. So let's AI robots are used in agriculture. So AI robots are used to enhance the process efficiency, increases the yield of crops, There are use cases which are used for robo picking, harvesting, and weeding. So one may see, oh, we are employing a very expensive technology for agriculture because we are from India and we are highest in the population with a working population as well the highest in the world. And we are not using it. But when compared to, for example, Japan, where the senior population is quite high, as well as in Europe, uh, there are there are harvesting seasons where people are not available for harvesting, and they use robots, they use combine harvesters for agriculture purpose. So it is selective in the region where the robots are used as well, right? For example, robot picking is used. For example, if you are trained through the computer vision, robot picking is used to find out or let's say harvest a particular product, when to pick, how to pick, so that the wastage is not done. So it reduces the wastage. So this is an example of how, for example, shadow robot dexterous for hand picking for precise fruit plucking is used. Again, the sometimes in Europe, if you there are something called seasonal employment, where you can come and work in Spain or Greece for olive harvesting as well. So they train you. You can live in the farm. You will help the farmer, and you can so accommodation is free as well. So people are using it because they are unable to get people. And imagine a robot being helping them will increase the harvest, which is good. It's a technology boom. So again, it is depending upon the area or the country where it is used. AI in manufacturing. So we have seen how Omniverse, Nvidia, and BMW is using in manufacturing. That's an example where you can see in a production line car where the car is being assembled, welded, and quality inspected. So there are intelligent robots is using the assessment of real-time situation and take corrective action. So we have seen in the CNET video as well as in the BMW video. Also, it is used in damage control and quality inspections. So human, if we are doing the same job again and again, we have the capability, and if the concentration goes down, it leads to a quality defect product. While for robo, uh, since it's a machine, it can do the repetitive task again and again, maintaining a high quality, reducing the wastage in certain key areas. For example, in manufacturing of electric cars, where the rare earth metals are deficient, and we need to use robots for manufacturing this. We cannot use a human, which may lead to a faulty thing, leading to a recall of batteries, for example. So this is an example of where quality inspections and reducing the damage control is used. Some of the aerospace, for example, in the Tesla bot region, you can see how the Optimus can be used for future space explorations as well. NASA is using a rover in Mars for AI object detection. Airbus Simon 2 is also assisting robots. There are robotic arms developed for fixing up the International Space Stations as well. So these are all some of the examples or use cases where robot is used. The other key important areas where robotics are used is in a hazardous environment where humans may not work. Example, in nuclear reactor, nuclear waste management, where the risk is quite high, exposure can lead to cancer, etc. For decommissioning nuclear plants, it's it's used. AI in healthcare, for example, in case of any pandemic situations, robots can be used for treating the patients. We've also already seen robotic surgeries being performed across India as well. So robotics already are occupying critical capability within healthcare sector. AI is also used in transportation, self-driving cars, Waymo taxis from Google, I think, and also if you pay 12,000 on Tesla, you get the self-driving car. I'm not sure whether Tesla in India has the self-driving capability, but in US it is quite used. There are within Google campus, The taxi is used for dropping employees from one location to another location. There is videos as well. Uh, if you search for the Google campus using self-driving cars, there's a nice video as well. Last but not the least, smart home applications. AI robots are used for domestic household purpose, including cleaning and security. Amazon Astro Robo acts like a virtual assistant for security monitoring as well. So, so some of the use cases we have seen, and I would quickly cover or scratch the surface of responsible AI. I think in your session there will be a session for responsible AI in detail, but one has to know what responsible AI means. We have technology, but we also need to know how to use the technology in fairness and ethical way. So transparency, explainability, ethical governance, and bias mitigation are some of the key terminologies one needs to think before employing robots. That's called responsible AI. Um, I conclude the last section that Gen AI, robotics, GenOg are shaping tomorrow together. We need to harness AI responsibly, and we need to foster collaboration. And we should not, I mean, there are pros and cons to depend on the technology as well. Uh, there are concerns of unemployment, but looking at the way it goes, the technology, the intelligence is normalized in the near future. So with that, I would conclude the Gen AI and robotics. So now I'll open for the Q&A. We have last 14 minutes in the current session. So if there's any question, I'm happy to take. Okay, maybe I will ask some of the keywords that you've used in GenAI in the steps. Can you list down one or two keywords, how GenAI is used in the parsing in the neural networks? Give me one word which is used for parsing. It starts with T, ends with R. Okay, it's called transformer. Yeah, maybe I'll utilize the last few minutes um, to share this video. So this is a video which is interesting.
If the control systems, sensor data, or decision-making algorithms of Optimus were ever leaked or hacked, the consequences wouldn't just be physical damage. They could pose a direct threat to human safety. Imagine thousands of Optimus robots operating in factories, hospitals, or even homes. A single software vulnerability could allow hackers to take control and turn them into tools for disruption or harm. For instance, you might ask it to fetch medicine, but it could hand you the wrong one due to a compromised command. That's why Elon Musk and the Tesla team are building a multi-layered security ecosystem, including data encryption, real-time monitoring, AI firewalls, and automatic safety lock mechanisms that activate whenever abnormal behavior is detected. Tesla has stated that it will develop secure remote control protocols, allowing humans to intervene immediately if a robot ever acts beyond its permitted boundaries. However, what's truly noteworthy is that, unlike electric vehicles or standard software, a humanoid robot can learn and self-adjust its behavior through machine learning. This makes it extremely challenging to ensure that Optimus doesn't learn the wrong things or get tampered with during its training process. Every advancement in the robot's cognitive abilities also means an increase in security risks, which is why Tesla must tightly integrate artificial intelligence, tech ethics, and cybersecurity. In short, Elon Musk has emphasized that the Tesla bot must be completely safe before it's made available to the public.
Of course, we need to make sure Optimus is safe and everything, but I do think we're headed for a world of sustainable abundance.
Right now, Tesla's focus remains on something far more practical: household chores. This stage of development might seem modest compared to the robot's long-term ambitions in factories or even Mars colonies, but it's a crucial first step. Elon Musk understands that for the public to truly accept humanoid robots, Optimus must first prove itself useful in daily life. A robot that can tidy the living room, fold laundry, or prepare a simple meal will have a much easier time earning the trust and curiosity of customers than one performing complex industrial tasks that feel distant from everyday reality. For decades, when people imagined robots and artificial intelligence, the images came straight out of science fiction. Gleaming androids, from movies like I, Robot, walking, talking, and serving breakfast in futuristic kitchens. But in the real world, that dream felt impossibly far away. The idea of a machine casually standing in your kitchen, making a sandwich, or reaching into the fridge for a drink seemed almost absurd.
Yeah, so this is an interesting video how the GenAI is looking at. So there was a question. Yeah, thanks, Narasimhan. Robotics is a field where AI plays a major role. The field exists long time ago. What is the current AI techniques that helps to integrate in robotics? We have seen GenOg is one integration for training and simulation purpose. Karthikeyan answer to the question. And so that's one part. And then we have the LLMs, the large language model. If you want to communicate with a robo and for it to break down and understand, it requires LLM. So it's a voice integration. You can talk about LLMs, large language model. These are the two things, the current AI techniques that's integrating robotics. The other one which I wanted to show is the warehouse. So it's a 12-minute video, but you can see how the DHL robo is used in a complete warehouse. So we have time, so I will quickly show you that as well.
This is Europe's first stretch robot in a DHL warehouse. And this is me trying to understand how it operates, with help from this expert who knows it better than I know Gen Z brainrot memes. But Stretch is just one of several robots we will meet today, and some of them operate in ways you wouldn't expect. Let's say you order sunglasses online. You want them delivered fast, right? This is where robots can help. But how exactly do these robots function? And what is it like working with them? More importantly, how can we rank them? Today we are traveling to the UK and spending a day with robots to answer these questions, starting with our first robots, these little fellas. Definitely not an S tier. Okay, it's time to get serious. Welcome to the future, aka Coventry in the UK, where one of DHL supply chain's most advanced and newest warehouse is located. So, what is our plan today? We're gonna spend an exciting day together with robots. We're gonna meet also the people who work alongside them, and we're gonna explore a little bit about the technology we use in these DHL facilities. So join us for this journey. It's gonna be exciting, and without further ado, let's go. Come. Let's meet our second, well, technically our first robot, the 6RS or Chuck, the 6 river system robots, which we use in this warehouse to help our colleagues in their work, basically. And this one is called Whitney. Nice to meet you, Whitney. She technically said hi, so I don't know if I've been ghosted. This robot is helping our colleagues in the picking. Basically, what it does, it goes through these shelves and then it indicates which item should be put into which box. And then the colleagues scan the item and the colleagues know where should they put the item. And this facility is not the only one with these robots. We have over 750 assisted picking robots and over 2,000 robots in total across our sites in the UK, Ireland and the EMEA region. Did we come from there or? I think we got lost. And now let me introduce you to some of our colleagues. Meet Hendrix, Dolly, Slayer. Can I just say like that's a pretty cool name? Vam, Riri, and of course, Quimby. And since all of these robots have names here, how would you name these two robots? I would say not from these 6RS or Chuck robots. They are helping our colleagues and I give it an S tier. And now it's time to meet our next robot. We just found out that there is another robot helping us in this warehouse. That's right. Meet the wrapping robots, basically the pros of packing. They speed up the stretch wrapping process, help protect products from damage, and even save on plastic waste. And the cool part, they've got different wrapping styles, so even weirdly shaped items can get wrapped up safe and tight. They are definitely S tier, if you ask me. But before we move on to the next robot, in this room we have 20 3D printers and all that stuff that was printed using these 3D printers. And yes, I counted them myself. Wow, look at this. Look, there is an octopus. Hello, I'm a 3D printed. I'm here with Steven. And would you mind telling us what you're doing here actually and what is this place? Because it looks absolutely amazing.
I look after everything that goes on within these four walls.
Oh, I can already see them. And just like that, the Locust robots enter the scene. So if you would have to explain, why are we using the Locust robots and what are they doing to help us to become more productive?
So from a Locust Robotics perspective, and certainly from a customer perspective, one of the real key things and drivers of using this type of equipment is productivity-based increases. By having the robots do pretty much the legwork for us by going to pick location, it allows our operatives to look for the flags, interact with the robot and then move to the next robot. The robot then does all the legwork and goes to the next location and another operative may interact with it. By the time 2 or 3 people have interacted with the robot, the order is complete. So instead of walking all the way up and down aisles, we're walking all the way up and down looking for flags. Half the amount of walking, more productivity, quicker products out the door. The other part of it is, and a real major part of it, certainly from our colleague interaction, is that there's no push-pull with the Locust robot. So the health and safety benefits from using this type of industry standard operational piece of kit means that we're seeing a minimalistic number or 0 health and safety incidents in regards to this area.
Okay. It's last 3 minutes, so it's interesting video watch, but how robotics are in place now, and how humanoids is interacting, and how in the near future humanoid you can employ humanoid instead of employing a human being for your house help. So that's not a sci-fi movie, but Tesla might make it real. So with that, I will finish off my presentation. Thanks for your time, and excuse for some of the technical glitches on the sound, etc. Yeah, thanks all. So I will log off. I think you can continue for the next session.
No questions? No questions for you?
Looks like no questions.
Any questions?
Yeah, there were a few questions that's answered. I use the rest of the time
Okay.
for the new videos. So
Okay, great. I'll just request you to share this deck with me
sure.
so that I can share it with the participants. And while we are just waiting for our next, first of all, thank you so much, Pramod. Thank you for taking the session and for sharing your insights with all our faculty members. Thank you so much.
Yeah, thanks, Kamna.
And I hope the weather improves for you.
Yeah, I don't know. Sorry, I got catch cold in this session as well. So hopefully the weather improves.
Yes, yes. I think probably the network issue was also because of the, probably, does
Maybe,
it?
yeah. I was not
Right.
sure because I have a high-speed internet. Yeah, with yeah, not sure it's 1 Gbps line, but it's a
Hmm.
wired optical line. So I think it's mainly because of the headset or something which didn't work well. Yeah,
No, but I think we once we told you after that you did the system sound on, and I think after that it was quite clear.
quite. Yeah, I had to restart and change the headset, so it worked. Thanks.
Right, right. Thank you so much. When are you
Thank
coming
you.
to India next?
Actually, I'm flying tomorrow to Chennai, so yeah.
Oh, lovely. Are you going to be in Delhi?
No, no,
Are
not in
you
Delhi.
planning to visit
I'm for a
Delhi?
family emergency. No, no, no. I'm for a family emergency. I have to travel,
Oh,
but I'll be there. Yeah. If I don't know which route I'm taking, but if I'm there in Delhi, I'll stop by. Sure.
please let me know. We'd love to catch up
Sure. Yeah. Sure. Thanks.
if
Thank you.
possible.
Thanks.
Yeah. Okay.
All.
Thank you so much.
Yeah. Thank you. Bye bye.
Thank you. Faculty members, if you have any feedback, please share it on WhatsApp. You can share a video message or you can share a WhatsApp message with me. Both are okay. Okay, a lot of you are saying that you have not received the welcome email from Future Skills Prime. Now, the thing is that your accounts are already created on Future Skills Prime because, as faculty members, probably there are cohorts of your college which are already there on Future Skills Prime. So, that's why you would not receive a welcome email because you're already on Future Skills Prime. So, what you can do is you can just log in using your registered email ID. Your password will also be your registered email ID. So once you do that, you can reset your password and then go to my group. So you will see this group AICT Atal Online FDP Generative AI Fluency. It's a closed group and we've provided an assessment over there which you can take. Please take that assessment only. You don't have to pay any money. You don't have to pay 600 rupees for the assessment. So just take this assessment as, and I've shared the images in the WhatsApp group also for where how you can access the course and how you can access the assessment. And I'm very happy to welcome Akbar Mohammed, who's joining us from Mumbai. He is Director AI at Fractal. Welcome, Akbar. Welcome to this session. There is something with your, I cannot hear you. You're not audible. Yes, yes, you can join back. Yeah, we are also not able to hear you. So I think today probably there is some network connectivity issue. So our trainers are having some difficulty. So I hope the process of joining FSP is clear, which is Future Skills Prime. I think one third of you are already registered on Future Skills Prime. That's why no email has gone. I checked in my system also. So you are already registered on Future Skills Prime. Miss Vijay Lakshmi. I'll just read out the names. Yeah, Miss Sangeeta, because your account exists, so you just log in. You log in with your registered email ID. Your registered email ID is your password also. And then you can reset your password. So Miss Sangeeta, Miss Vijay Lakshmi, Miss Vijay Lakshmi has just done that process and she is now able to uh, access the thing. Same thing is with the others also. Please try that.
हाँ मेरे भी खत्म हो गए थे खराब हो रहे थे मेरे को तो देखो
You can mute yourself. So some of you, I think, Miss Shivani, you also are already registered on Future Skills Prime. Mm, Akbar, are you able to hear us now?
Yeah, I can hear you. Can you hear me okay?
Yes, yes, we can
Okay,
hear you now.
perfect.
Now it's yes, yes,
Okay.
yes, yes. So I'll just, I was saying that we are very happy to have you with us. In fact, we are privileged to have you with us, and I introduced you.
Okay.
So you are Director AI at Fractal. You joining us from Mumbai, and it's great to have you. And the quick word about you is you're very passionate about technology and using technology to solve business problems and at enterprise level. And our faculty is really lucky to have you share this session and your insights with us. So over to you.
Yeah, thanks, Kamna. Uh, I thanks, folks, for being with us. I'm quite excited. Today, I want to focus on healthcare, and for that, I'll quickly share my screen. What I've done is I have basically tried to collect stories, both from your curriculum and from my own experience of working in healthcare. I'll talk about how AI has evolved, specifically in healthcare, and how it's changing some of the enterprise level and even broad solutions in healthcare, right? And that's what I have for you. I'll probably quickly take you through the agenda, right? Before I begin, I want to talk to you about the ecosystem and specifically the data ecosystem. Anything AI has to start with data, right? So I want to talk about the rich data that we have in healthcare, and then I picked three broad areas. And again, healthcare is very wide. For the time that we have, I thought I'll pick three broad areas where AI is impacting and the diverse ways in which it is impacting healthcare. And then lastly, I also want to talk about what is working, what is not working, how does the future look like. So that's what I have for you. With that, I'll quickly jump into the first section about healthcare itself, right? The data itself, right? Now think about any interaction with you have, whether it's a doctor or hospital or caregiver, whoever, right? Imagine the number of touch points that you have, right? You walk into, let's say, a hospital, you're filling up a form with a receptionist, and then you're probably walking into to the doctor's office. There, a bunch of notes are taken about you. Then you may also go to follow-up visits where you're maybe having a blood test, an X-ray, an MRI, and there are many other tests that you go through, right? So each of these interactions are actually data points. And so yeah, this is the image, right? If you're a patient, there are many touch points that you have. You may have with doctors and nurses. You may have with pharmacies, labs. You may also have with financial teams. It could be your employer's financial team, or it could be insurers. And there are many things that you go through as a patient. And each of these interactions has some data element. And it can be part of care delivery, support network, industry players like pharma. What all of this is primarily unstructured data. So think about doctors' notes, nurses' notes, prescriptions. They are very technical. They are very specific to the healthcare world, and all of that is being documented in a very unstructured way. And the reality today is that this unstructured data hasn't been fully exploited, at least not until a couple of years ago, right? So 80% of the data which you see here is unstructured data in healthcare, and only 20% of this data which is structured gets exploited. When I say exploited, I mean people analyze it, synthesize it, make sense of it, get insights, uh, things like that, right? The other interesting thing is globally, healthcare data is growing at 36%. That's a very high rate for data to be growing at. Both of this combined is actually a huge opportunity for GenAI. And why GenAI specifically is because traditionally, when we used to work with machine learning models or predictive models, you used to work a lot with structured data. When I say structured data, think of it like anything that you can fit in an Excel or something that looks very tabular, that is structured data. That was easily accessible. Easily we could work with it and build models out of it. That was the limitation with AI models before GenAI came into the picture, or even any deep learning model came into the picture. But now we're starting to use that more extensively. And the first few places, and I'm going to talk about this a little later, is a couple of areas, right? Like doctors facing burnouts. How are we using AI there? There are healthcare costs, and this is huge health costs. These are inefficiencies in healthcare. Depending on which hospital you go to, the operations might be very different. The way they manage their hospitals are very different, and specifically in the developed world, it's while it looks best in class, but the way it's managed is not extremely efficient. And those inefficiencies kind of show up in costs. So there are about $4.3 trillion worth of healthcare costs that are potentially out there, which we can potentially save globally if we can bring in more technology, more automations, better processes. So that's the opportunity that we're tackling with, and AI is effectively going to play a large role in this zone to help us solve. I'll come to it when we go through the exact solutions. Now, 80% of unstructured data, that's actually a gold mine. It's a huge gold mine for different various reasons, not just for administrative perspective, but also from a research and analysis perspective, right? And we also know that this data is growing. Up until the 90s, the techniques, the compute available for creating new healthcare solutions was limited, but it improved in the early 2000s, and now it's at a point where there are proteins that have already been unpacked. Like all the proteins that we can synthesize have already been unpacked because of GenAI models, not even GenAI models, deep learning models. So there are many solutions that have come up because now we can synthesize this unstructured data. Okay, and what that essentially unlocks a couple of things, right? It helps us improve automation, you make better utilization of healthcare costs, create new solutions. It could be anything, right? It could be diagnostic solutions. It could be like wearable tech, where you have algorithms and AI trying to figure out what your heartbeat beats are trying to tell you. So there are many solutions that are being unpacked, and all of that is possible because we have AI and we are using unstructured data to train the AI. Okay, so that's the first thing I want to highlight. There is a lot of data, and that data is increasingly being exploited today because of the evolution of AI and the place we are with AI today. Okay. Now that leads me to the second section, which is patient care. And this is a common place where most solutions end up being. Like I said, unlike traditional AI that need a lot of clean data, GenAI can learn with messy data. And it could be any kind of data. It doesn't have to be numerical. It could be visual. It could be audio. It could be even things like LiDAR, radar. It could be any data, really. And you can pass it to a deep learning or a GenAI model, and it will be able to synthesize all that information and make sense of it. So that's the power we have today. And it not only can give you insights and recommendations, but it can also create new solutions, like being able to predict, being able to simulate. And that's what I want to take you through in this first section. There are two broad zones, and this is not the only zones, but this is what where we are seeing a lot of solutions being created, which is transforming patient care. The first one is in imaging, understanding medical images. Up until 2014, understanding images was very difficult for machines. It's only when we started to annotate datasets. I think we started with very simple datasets like dogs and cats, faces, that simple data set, training that simple data set allowed us to kind of exploit more advanced techniques. There were two things that were happening at that time. There was I don't know if any of you have heard about big data. There was a lot of digital transformations that most organizations, not just private organizations, but also government organizations that were going through this transformation where they were bringing all of their data into a zone which can be processed further. Right? That was happening in early 2010s. So we had data available, and this was both structured and unstructured. Most of it that was getting processed was structured data. And the second thing that was happening was they were increasing compute power, right? I remember when I started my career, we used to have 2 gigs of RAM, 4 gigs of RAM, and putting like a large data set into a machine was extremely difficult, right? You can't process that size of data. But in early 2010s, that became like a norm. All data was very huge. We had to figure out ways to solve those problems. But the problem, the third problem that we used to struggle with is techniques. The techniques, when I say techniques, I mean the ability to process this data and make sense of it, like predictive models, analytical models. Those were limited, and it used to be mostly statistical models in the beginning, and later we started to exploit machine learning models. And in 2014, there was an interesting set of deep learning techniques called convolutional neural networks that started being exploited. That allowed us to interpret image data. Okay, basically, if you pass an image, it could easily identify, okay, this image contains a number, object, or many series of objects. Right? That same technology or same technique combined with technology is now being used in various places like radiology, image generation, and things like that. I think the main one I'll probably focus on is on radiology and synthetic image generation. In radiology, one of the key challenges is figuring out issues early. Okay, like radiologists go through many years of training, both from an academic perspective and also from a practice perspective. Right, they have to go through real world experiences before they can actually diagnose anybody correctly. What we can now do is we can make an AI go through that same level of training at scale. I mean, you can imagine the range of problems that different radiologists go through. You can train an AI model to learn all those. And that training allows us to detect issues at pixel level, right? If there's a minor issue, even at a pixel level, an AI is able to identify it more consistently. I won't say more accurately, but more consistently than any human radiologist. There have been studies done comparing how an AI performs against a panel of radiologists. And usually the AI comes on top. So that's happening. We are now using AI to scan issues, specifically rare diseases, where there is limited training data, right? And that's one area where GenAI is helping. Okay, I see a couple of chats. The second one is actually second and third one is synthetic data generation. Now this is actually quite interesting because earlier we had a lack of data specifically in in conditions that we haven't studied enough, right? And the other problem is in healthcare, patient data is not easily accessible outside the patient-doctor relationship. So if you had a MRI or a X-ray or any kind of clinical interaction where some records are being kept, by law in most countries, that data cannot be shared. So people like me who kind of work with this data quite often, we can't get access to this data unless you are diseased or there is a national program that gives us access to this data. Right? That limited our ability to create solutions on top of this data. Right? So one thing that GenAI started to help us with is creating synthetic data. What you could now do is you could train AI models with a bunch of real world data and ask the AI model to create synthetic copies of that data. Maybe I'll give you an example. Let's see if this works. This person. Okay. So there's a site called This Person Does Not Exist. There are many versions of this. This cat doesn't exist. This dog doesn't exist. What this essentially is it's an image that is generated by AI. If you look at the quality of this image, right? I mean, from the hair to the proportions of these eyes, the skin tone, and you can generate millions of them. Like I can press refresh and it'll generate another one. And this is possible today because there is AI models that are trained on human faces. Now imagine the same thing in medical images, right? You can create scans of the human body. You can also create scans of, let's say, rare diseases or different diagnostic issues that people go through, and train the AI model to generate synthetic copies of that images. Now, the reason why synthetic copies are important is because it retains a lot of the I call it signals, right? In our world, there are signals. Like what I mean by signals is the details. Like, for example, in this person's, the hair quality, like him wearing a glass, the skin tone, everything. There's a lot of detail that is retained here, right? That same detail can be retained in synthetic images. Now, what that does is it allows us to share that data and go out of that constraint of not being able to share real world data, right? And then you can use that synthetic data to create solutions on top of it. And there are two famous examples. I think NVIDIA has this image scan where it can create medical images. King's College has another one for brain. And these image generation can be very specific. You can say, I want to generate images of only the eye, only the brain, or let's say the nervous system. You can train the model to do very specific synthetic image generation. And this has unlocked a lot of things for us to be able to create more solutions on top of it. Okay. And and the key technique that is powering all of this is called generative adversarial networks. This allows us to create these realistic medical images. So that's the first range of solutions that we are unlocked or have already unlocked in many places. And we are currently exploiting them to build more solutions on top of it. Okay. The next one is on personalization. Okay. In healthcare, most diagnoses or most treatments are generalized. What I mean by generalized is we take averages. Right? What I mean, averages in the sense like, hey, this particular drug works for 99% of the population, right? That's the and with this level of confidence, that's what we do when we create these when healthcare professionals create treatment programs. Unfortunately, people are very unique, right? We have different ethnicities, our bodies have different characteristics, both physiologically, psychologically. That was a limitation earlier. Now what we're doing is we're using, again, AI to create treatments that fits one person, right? You can take like your genetic makeup, your lifestyle factors, or maybe your medical history, and come up with a treatment plan that fits you exactly. Okay, that is happening today. Mayo Clinic is doing this very extensively. As of 2022-23, there were 100,000 patients that have gone through this personalized treatment that is generated by AI and a bunch of other techniques. That is happening. Like personalized treatment is already happening. And the other one is around drug discovery. Drug discovery using AI is probably something that most pharmaceutical organizations are trying to exploit. Google Cloud and Jinko have already created this protein LLM, right? The LLMs or the chat GPTs, Geminis that we talked with are language LLMs, right? They have created an LLM that focuses on protein molecules for drug discovery specifically. So if you're a clinical expert or a pharmaceutical expert, and if you have a drug idea and you think a bunch of molecules can work, you can feed that information and try out if a particular drug can be discovered. So that's another thing that is happening. So drug discovery is a very serious uh, implementation that companies are doing. I believe Merck is already going to release, or at least have come up with, a drug that is synthetically generated. What I mean synthetic is they've used AI to create that drug. It's not like 10 years of research where people experiment and figure out what molecule works. It's basically done. All that 10 years of work was done within a few months. Now it's going through the various FDA prescribed trials, right? So that's already happening. Yeah, so that's personalization. So this is the second area where GenAI is helping, specifically in patient care. Okay. I'll pause here. I'll see if there are any questions, and feel free to ask me questions if anybody has one. I'll probably pause in different moments and see if people want to understand anything more deeply or have any questions. I'll just give it another 10, 15 seconds and then we'll move on. Okay, if there's nothing, let me move on to the next one. Okay, Mahalakshmi, you said demo. Demo of which one, Mahalakshmi? Demo of synthetic images? Okay, I'll come back to that. Maybe if it's a synthetic image, I can probably show you examples. Okay, I'll come. Okay, medical images. So this one that I'm talking about, right? This person doesn't exist. Okay, maybe I can show you this cat. Okay, this X-ray synthetic. And there are many examples of this, right? Synthetic MRI images. Right? So there are many implementations of this. You can, okay, there are companies. Okay, maybe this is a good publicly available data, right? This image that you see here, this is not of a real person. This is an AI trying to basically fake what a human image might look like. And to be able to fake that image, this image of a real person, it had to learn from many mistakes. And the way it would learn from those mistakes is we would give it real world data of real people, and it'll try to imitate what that real world data might look like. And for that model to learn, it has to understand the different features. When I say features, think of hair as one feature, think of the distance between the eyes as one feature, or the distance between the ears. So there are many computations that are happening that the model has to learn. Even the pixel color, right? To be able to generate that a skin color is of this particular type, it has to understand that feature very well, right? So all of this is kind of embedded or compressed. All that knowledge is kind of compressed in a model, in an AI model. And that same compression technique. So here we are using human faces. So imagine using medical images instead of human faces and training the model. So it could be something like a human anatomy. You could scan real world human anatomy data, train a AI model. The AI will learn all that knowledge. It will compress it. And then you can access that compressed knowledge to create new kinds of anatomical variations. So this one is actually a fake image, right? I can press refresh again and I'll probably create one more. Again, this person may not exist. Now, if you notice on the left, it tried to create a second image, but it was pretty poorly done, right? So it can make mistakes. But if you look at this image, it has a lot of the features that you would expect in a real person. The same thing can be done with medical images. Okay, I don't have a working example. That might mean I either purchase something to show you, but maybe I can share the link after the session about different papers, right? There's this Python MRI which you could run. It's a open source platform, right? I can probably paste this link. Right? So this can generate, I guess, cranial scans, and you can create many of them using this, and it's already a trained model. Maybe I'll paste it here, right? So these are some real world implementations, and you'll find many of this. I mean, this is for cranial scans. You can find implementations for dental scans, for retina scans. What is there? Even like liver scans, and all of these things are important for the medical community, because once a model has learned like what a normal, let's say, human body looks like, then the abnormalities are easier to capture, and that's a key feature of training models. And the second thing is not second thing. The first thing is, because this is synthetic data and it's not of a real person, I can create the synthetic image and share it with you and say, look, this rare condition tends to have these features, and we should be careful whenever we see this pattern, right? Those things are now possible because we can share that intelligence with other people, right? That's the other thing it unlocks. Okay, hopefully that answers your question. Okay, I'll move on. Okay, perfect. Now the next one is on clinical documentation. Now this might sound very benign today, but it's actually a very powerful implementation. Okay. Now when you walk into a doctor's office, you may have like what would seem like a 10-15 minute diagnostic conversation where the doctor might ask you a bunch of questions, and he may diagnose you, or he may study your symptoms. All of that is both a normal conversation, and they may also be elements of clinical conversations, right? A very simple idea here was to have an AI who is listening to that conversation and documenting it. And you will see many such devices in the market, or many such implementations in the market today. But that simple thing helps solve a huge administrative burden for physicians specifically. Anytime you walk into a hospital and have a interaction, by regulation or by practices across the world, doctors are expected to document their conversations. And when I say document, they have to go back, write the notes either in a file or in some computer system. Usually today it's some computer system. Either they are doing it, or their nurses are doing it, or their admin people are doing it. That's a lot of administrative burden just for that 15-20 minute conversation. At least even today, most doctors spend about 60% of their time on administrative tasks and very little on actual diagnostics. And that's the general consensus. And that led to a lot of burnout. Physicians who get trained to solve medical problems, instead of actually solving medical problems, they are doing administrative work, and that used to lead to a lot of burnout. And on a daily basis, they spend like 2 hours just writing notes. Now, this simple device that's listening into a conversation, documenting it, it kind of relieves the doctor, and it allows them to focus on the patient. Okay. And the second thing it does is it reduces the errors. Like a doctor might forget what he told the patient, right? But the machine might remember. And training this is not an easy task. The AI that has to be trained, it has to know language. It has to know what a medical terminology is, what a clinical terminology is. It has to understand all this, right? And with that context of that patient-doctor interaction. And this is the third aspect of security, privacy, and things like that, right? All of that has to be taken care of when creating the solution. So a simple device that can listen into a patient-doctor conversation or any medical conversation, document it, is actually a powerful example of GenAI implementation. I'll talk about this again later. This is one of the positives of positive implementations of GenAI. It has immediate use, and doctors are finding it very useful also. And there are many implementations. There is a Microsoft Nuance DAX. There is an Epic GPT-4. There are many. These are just two examples that I happen to write here. But there are a couple of examples that many more examples you'll see in the market. Okay. And these are some of the benefits, right, which I talked about. And the other thing I want to highlight is, and this doesn't have to be limited to one language. You can go into a clinic, let's say in India, and you can speak some of it in Hindi, some of it in English, some of it in Tamil. The AI should be able to detect, translate, and document it in a very consistent manner. Yeah, that's the powerful thing about Gen AI that is out there today. All right, this is the second example. Okay, the third example is around claims processing. Now we are moving out of the clinical setting and going into the healthcare insurance space. In healthcare insurance, there's something called as prior authorization. So depending on the product you use, there might be certain conditions or interactions with healthcare that can be claimed without a lot of processing, which is basically called prior authorization. On average, it takes about 10 days for these authorizations to happen. And this is a very manual process. It has to go through a bunch of reviews by people. It'll be an administrative review, there'll be a clinical review, there'll be a risk adjusted review. So it has to go through a series of reviews. And these reviews are not very complex. They're looking at a few heuristics, like is this claim real? Did the doctor prescribe correctly here? Is this excessive, not excessive? Things like that are being assessed in this prior authorization process. What is now happening today is, unlike this traditional process, which is manual, we have AI-assisted processing. Right? Instead of you having to fill up a form, go through a series of steps to get that claim processed, you can just submit your receipts and what the doctor has diagnosed and prescribed. And that data will get synthesized by an AI, and it'll go through that same manual reviews, right, using an AI. So there might be a admin review AI, there might be a clinical review AI. All these AIs can look at many data very fast, and you can practically get the authorization or the claim processed within the same day. This is happening in healthcare. It started with non-life insurance, car insurance specifically, and then it kind of moved to healthcare. In car insurance, let's say for example, if you have an accident, earlier you would show that accident to a person like a adjudicator, and they will review it. They will propose a claim. So there's a lot of things. I think it still happens today to some extent, but now in most advanced countries, you can simply take a picture, submit it to your insurance company's app, and an AI will make that assessment based on the picture you submit, and give you the like a payment or whatever needs to be processed immediately, almost instantly. That used to happen at least until a few months back. But now the AI has become so good that you can actually fake these accident images and bills and prescriptions, right? So it's created more problems. But the technology exists to help us automate or process claims much more faster. So there's reduced dependency on humans to make manual reviews. So this is another place where GenAI is helping specifically. Okay. The other one is on fraud detection and compliance. Fraud, if people don't realize, fraud in healthcare is massive. It's as big as fraud in the financial world. You could have fraud with intent or without intent. What I mean by that is there might be doctors who intentionally, like say, prescribe a more expensive medicine, but in reality only implement the cheaper one so that they can benefit from that excess admin funds, right? They could be unintentional costs, right? Maybe the admin of a hospital makes a manual error or a human error, and that gets processed. That is also kind of part of the waste and abuse category. All of this adds up, and it adds up to billions of dollars. It's not a very small number, and this fraud can happen in different areas. It could happen in insurance. It could happen in pharmaceuticals. It could happen in drug prescriptions. There are many areas, right? What we are now doing is we are using AI's ability to look at fraud in a multi-dimensional perspective. So earlier, fraud used to be segmented by the nature of fraud. So if it is let's say, billing pattern fraud, we'll have one machine learning model to detect billing pattern fraud. Or if it's about pharmacy fraud, there'll be a ML model for pharmacy fraud. So we used to have many different fraud detection models. Now with AI, which is able to kind of learn from many different unstructured data like medical images, billing behavior, audit trails, even many languages, right? So we have one or fewer sets of AI models that are looking at multiple perspectives and detecting fraud. What this allows us to do is it allows us to catch more complex, more sophisticated kinds of fraud. So that is happening because of the AI's ability to capture those features more effectively. Okay. There were limits in traditional approaches. They were not able to read handwritten forms, voice recordings, or even different languages, right? That limits have been broken. So we are able to detect more fraud, more complex fraud, and we are able to detect them earlier than we used to based on traditional methods. So that's another space we are improving. Okay, I see some questions. Okay. I see a question from Usha, like, aren't all models highly data driven? And how does it apply to remote villages where data aggregation is rare, right? Okay, I'll go back to the previous things that I talked about, right, where we are generating synthetic data sets. And synthetic data sets are really powerful because you can train a model with, let's say, a large corpus of what is available, like, let's say, non-remote area data, or let's say we know how a normal body looks like, or normal human uh, images look like, and you can provide a smaller sample of things that you have observed. It could be rare diseases, it could be maybe diseases which are only isolated to specific regions, and you can essentially provide that intelligence or that data set to a AI model, and it'll be able to figure out what is normal, what is abnormal, and that deviation itself is a data set that it can basically, we call it a distance in feature, right? What is the deviation from the norm? That itself is a data set, and once you know that deviation, you can synthetically create more of them. So you can create small variations of that pattern, and create more copies. So effectively, what you're doing is you're creating more synthetic copies of data where you don't have enough information, and you can use that to maybe build solutions or increase the accuracy of some of the insight generation of models that you're creating. So that's the powerful feature of GenAI today. So today we're not limited by smaller data sets. We can train a large model, and then you can give something unique or something that you have just recently learned, and the AI can figure out what this deviation is, and use that deviation to create more copies of that data, and then you can use that data to create more solutions on top. Most AI models today are essentially that. There was a concern that if there's only data that is being generated by AI, then the quality of models will decrease, right? That is not true. Claude, Anthropic, OpenAI have actually proven that even if you provide synthetic images, there is enough intelligence in these large language models to understand these newer patterns, even from synthetic data, to bring out insights, create more solutions on top of. So the concern is not very high of having more synthetic data sets being used. So that's how you could use smaller data sets, like large models, to learn patterns from smaller data sets and then create more synthetic images and then build solutions on top of it. Hopefully I didn't confuse you. Maybe that answers your question, Usha. So data aggregation is not a limitation today. Even if you collect very small samples, we are able to use GenAI to create larger samples from that smaller data set. That's the power of GenAI that we have now. There's another question on AI tool is best to analyze medical report. I don't have one name that comes up to mind, but most medical solutions, they're not fully open source. I can probably maybe send some after the class. There are some open source implementations that you can borrow. You will find them, many of them, in your Nature or Nature Science journals. They will already be there, analyzing medical reports. Yeah, you're right. Physiological makeup will also differ. These are things that you have to kind of feed into these models now, because these models are able to interpret all of that. So far, what I've been talking about is just imaging related data. But if your model is multimodal, what I mean by multimodal is it's able to interpret image, video, language, then you can also provide that psychological or physiological aspects as inputs, and it can use what it has learned to come up with new synthetic samples. Um, hopefully that answers your questions. Okay, I will move on. Okay, the third zone is population health intelligence. So far, we focused on the operating level of healthcare. Most countries now have um, population level intelligence gathering. What I mean by that is think about a national healthcare program. How many hospitals should this region have? How many beds does it need? Are there risks that we need to manage for people of at different ages, right? You may have children, you may have the adults, you may have senior citizens. How do we manage the health of the overall population? And what programs should we create to manage the health of this population is actively something that most governments look at. I think even India has its own programs. India manages things very differently, but these programs exist. And they tend to be very data driven. And now, because of the advances in AI, we are starting to use GenAI in very unique ways, specifically in population health intelligence. And one of the ways is simulating various interventions in scenarios. And it's also become very cost effective. Okay. For example, how do we evaluate the impact of a particular program before the deployment? How do we ensure it is effective with the resources that we have? All those simulations can be done because of GenAI. And there are a couple of areas that I have collected. The first one is around synthetic medical data research. I think I touched upon this earlier, right? Earlier, since we have restrictions on sharing data, so let's say if somebody in France has found a new rare disease, it won't come out of France because most countries, most hospitals have restrictions, especially in these rare diseases. But it could be useful for somebody in remote areas or somebody in other countries where they're seeing similar symptoms and they want to validate whether it's the same condition or not, right? While that intelligence might be there, shared in some research paper, but the tools, the techniques may not be easily accessible. So how do you make it accessible was a limitation, especially from a research perspective. Now, because of AI, right, specifically synthetic data creation, we can share that. So we can have somebody with a rare disease, we can create a synthetic copy of that rare disease simulation or patient data and share it with another country. And that, in fact, you don't even need to share that synthetic image data. You can share the model itself, and then you can create more data. You can study that model to figure out, okay, what are the general patterns where this rare diseases or markers of these rare diseases can be identified. Right? So that itself is very powerful. And what that allows us to do is it helps us create patient trajectories, like how will this disease evolve. In let's say if somebody in France has that disease, how will that look like for a patient in India living in, let's say, Kerala, right? With their own genetic makeup, how will that look like? What are the symptoms that might differ? How will it change based on the physiology, the cultural aspects of that patient, right? All of that can be simulated, and the trajectory can be at least interpreted based on that synthetic image or synthetic data creation. The third area is around clinical trials, because we have a model that can practically generate unlimited data sets. We can simulate millions of these copies. Even if only you've studied maybe 10 patients with that rare disease, you can create millions of that data sets and figure out small variations of that rare disease to identify potentially other patterns that might emerge in the future. So that's possible with synthetic medical data. It helps researchers basically deep dive into issues, figure out, simulate different trajectories, and come up with newer insights. So that is possible today. And we can use this specifically for population level health, right? If you think about COVID, right? How would COVID evolve? I think at that point we had traditional models, but we could have used something like GenAI to see how the disease will evolve, how different treatments might evolve, or help reduce the population health burden. Things like that can be done using this technology. Okay. The next one is around predictive analytics. Now, predictive analytics has been there for a long time. This is not something new. And I'll give you like a range of analytics that we do, right? There is reactive analytics, which is basically you collect data, you study that data, and then you react to it. Like you see a spike in flu in, let's say, during the winters, and you get that data maybe at the end of the winter season, right? Generally, that because it takes time for you to get that data, and then you create intervention plans. So that's the reactive way of working with data. Reactive in the sense it also includes data analysis, right? So all that takes time. In the past, we used to start using predictive analytics. Even if we have small amounts of data, we can like add that to traditional machine learning models to predict what might happen, let's say next year or the next 3 months. What risks do we have in the population segments? Is the probability of risk increasing, decreasing? All those could be done through traditional analytics. Prevention and predictive were kind of difficult earlier. Not difficult, but it wasn't as accurate. Now that we have GenAI, or specifically the ability to capture these small nuances in a range of data sets, not just structured data, we're able to bring those features that an AI model learns and give it to traditional predictive analytics models. That alone helps improve accuracy and effectiveness of these preventive care predictive analytics. An example of predictive analytics is how do I know if a patient is at risk of diabetes? And this is just one condition, right? And diabetes is a very nuanced chronic disease. It's not very easy to detect it early on, but we have made attempts, and these are models that exist in the world today. Earlier, we had an accuracy about 80-85%. Like if we know the patient journey, let's say up to a particular age, I can predict in the next few years this person might get is at risk of diabetes. And this is useful not just from a patient care perspective, it's also useful from a population health perspective. Like you can identify segments at risk. You can create intervention plans. You can share that with the government and say, look, this region, based on their lifestyle or whatever, based on the data that we are seeing from practitioners, we can tell that this population is at risk, and the government can come up with intervention plans, right? So this was possible earlier, and and the window of or the effectiveness of these predictive analytics models was very low, right? 85% accuracy. We could probably tell if somebody can be diabetic within 6 months or so. But now, because of GenAI models, we can predict within, let's say, a month or so if a person is at risk of diabetes, because we have a small window to predict, right? And that small window itself is very useful, so that we can intervene or we can prevent that person from going, or not just the person, but the entire population segment from becoming at risk and creating a burden on the healthcare ecosystem, right? So that is what used to happen. Now those same models are leveraging these GenAI embeddings, as we call them. Embeddings are basically what the model has been trained and what it has learned. And that same learning can be plugged into traditional machine learning models, and they become far more accurate, um, much more accurate. You can do diagnosis more quickly. You can predict much more faster. All the good things because of the evolution of technique itself. Okay? Another example is emergency visit. I'll have to use the US as an example here. In the US, if you generally, if you have to take a appointment with a doctor, it could take months because there are not many care providers or practitioners. And the only way somebody in stress can get attention is if they go to a ER visit. Now, this may sound like it's a good thing, but from a healthcare perspective, it's actually a burden to that system. Because let's say if a hospital has 10 people in the ER facility, and somebody with a minor issue walks in, by law, they are expected to be treated. Now, if at the same point, there's somebody with a major incident or an issue walks in, because the resources are locked, that person cannot be served, right? So it kind of creates a hazard for both the patient with a major condition, and also it adds more costs because the ER facility is actually designed to work for emergency cases alone, but then when they treat non-emergency cases, the utilization is very bad. And if you add this up at a national level, the costs increase by a lot, right? So in here, we used to use a lot of predictive models. So as soon as you walk in, there's a series of questions that you are asked, and the AI model decides whether this is relevant for a emergency treatment or not. That alone, that simple interaction, that simple ability to predict if a person will need emergency visit or not, has reduced the burden by 25%. And this is very old, right? This is not even a model that was built a few years back. This is from 2018, 2019. And the return on this simple predictive analytics model is about 3x, almost 3x. Just having this helps improve the utilization, reduce costs, redirects patients to the right facility, and also helps plan how healthcare systems need to be utilized. Okay. In fact, some of these ER visits can be fully automated. You could have a virtual AI physician guiding you what to do, and you see that in some places already. I know many people use ChatGPT to do basic diagnosis. Well, I don't advise it, but it's available, right? Something similar is happening in healthcare ecosystem for preventive care. Yeah, so this is for predictive analytics. The next one is around health campaigns. I know many of you must have seen the polio campaigns that states run in India. There could also be like even in small pockets, there are for drug addicts awareness campaigns that governments put up. Now, usually these campaign or these public health administration is not funded heavily. They run on very thin budgets. What is happening now is that they are increasingly leveraging GenAI to create these health campaigns. Now, take the India context, right? We have different languages, we have different cultural nuances. There might be people who are afraid of healthcare in general. So there's no one size fits all campaign that will work. So how do you design campaigns? How do you design messages that is targeted to specific populations? It requires investment. You need people who can think locally, implement campaigns for that particular locality, right? That used to be difficult to run on scale with limited budgets. What we are doing now is we are using, or what is increasingly becoming common is we are using GenAI to create targeted approach. Maybe let's take polio, for example, right? Now, you maybe at a national level, you can think of, okay, I want to run a polio campaign. It has to go through every state, every district. In the past, you would probably do one campaign and just broadcast it everywhere. Now, what is happening is the district level entities can customize the campaign. When I say campaign, it's basically a message, right, or a pamphlet or a directive for different public health facilities. And that message can be customized to include demographic details, cultural nuances, behavioral factors, and then that message can be created. So it creates basically personalized health messages for different communities. And it can also come in different languages. You don't have to like worry about, hey, I don't understand Tamil, I don't understand Telugu. You can probably interpret it, give a LLM that intelligence. Hey, I'm doing this campaign for this region, and this region has these dynamics. Help me come up with different campaigns. And LLM will do that for you. So that's one powerful thing that is happening. This allows, like, it saves costs. Two, you are able to do this much more quickly instead of like waiting for months for a campaign to be thought about. You can do this almost within a week. So that's another space where GenAI is helping. Okay, before I move on to the reality of GenAI, let me see if there are any more questions. Okay, I'll come to this, right? Which space must be predominantly human intelligence? I'll come to this. I'll give another 10 seconds if folks have questions, otherwise I'll move on. Okay. Okay. So far we've talked about three broad areas. One is patient care. The second one is population health, and the third one is around intervention plans, like what has changed from predictive to GenAI. Now, what I want to talk about is what is working and what is not working. Like, there's a lot of hype about GenAI, and I want to share some of my experiences about what is really useful and not useful. Again, things are evolving, the models are also improving, but so far, until let's say middle of 2025, this is where GenAI is working and not working. And remember, this is only a 2-3 year old technology. So for that, it's already made a lot of impact. The first one is where GenAI is working is in time saving, specifically for physicians, where documentation is involved. Like I said earlier, most physicians or clinical care providers, they spend a lot of time in admin tasks. And those admin tasks is quite tedious. You have to write notes, you have to type into systems, you have to file these things with different organizations that you are prescribed to. All that is being automated because we have AI that is able to, one, capture those notes, interpret those notes, and then file them. That simple automation itself is leading to a lot of time saving and even physician satisfaction. A lot of physicians that we talk to, they are extremely happy about this. In fact, they want more of it in more unique situations. Maybe I'll give you a case study, right? There's a children's hospital in the US that specifically looks at spinal deformities and issues for kids under the age of 14. And it's a very specialized hospital. And over the years, the physicians that have written down notes, when I say written down notes, I mean practically like written down notes, handwritten notes. There's a team that has digitized it. And anytime a new doctor comes in, they come in with whatever training they have, whatever apprenticeship program that they have gone through, and then they start diagnosing new patients. What they have learned is that when a new doctor comes in, he may miss learnings that we've had from whatever 20, 30 years of experience that the hospital has had based on various physicians that it has interacted with. One of the things that we were asked to do is, can you embed that intelligence? So instead of the doctor using his own experience and knowledge, can he use an AI system where he plugs in what he is diagnosing for a patient, and then look for learnings from the past, and then using that learnings to make his recommendations. It may sound simple, but the AI behind it is fairly complex. That simple implementation itself helped save a lot of research and synthesis that a doctor might have to go through. So a doctor will have an iPad, and the iPad is listening in the conversation. And as soon as it detects that, hey, we had a similar patient in the past. Here are 10 of them. This is what we did to, these are the list of things that we did. This is the most effective solution that we have identified. And the doctor has the ability to decide whether he wants to go ahead with what the AI is recommending, or he chooses a different path. That simple system alone helps save them a lot of costs and errors, essentially medical errors. So that's a real world implementation where things are working for physicians. The second one is around diagnostic robotics. When I say robotics, again, this is when you walk into an emergency room or when you walk into a physician's office, a simple checklist that kind of goes through an AI model, and the AI model predicts, okay, this person might need immediate intervention, it's a non-immediate intervention, or this person has XYZ risks based on the interaction that he has gone through. That simple diagnostic tool, I'm calling it diagnostic robotics here, has helped many different chronic conditions, clinical conditions. In emergency visits specifically, it's been very effective, where we are seeing 3x return on investment. So 25% reduction in emergency department visits. This is across US, and 3x return on investment. So there it has been very effective. Basically, traditional models augmented with GenAI models, they're becoming more sophisticated and more effective at identifying issues. The third one is around personalized treatments. Up until 2022, it was more experimental, but now it's becoming, it's not fully mainstream yet, but at least we're at a place where we can say that personalized treatment is feasible. It's just that how do we bring it out ethically at scale is something that Mayo Clinic and most medical facilities are figuring out. But personalized treatment is known to be extremely effective, specifically when you're using GenAI models. Okay, with the 3 years that GenAI has been in let's say specifically US healthcare, we are already seeing about $200 billion in savings. And this is not just GenAI; it's AI in general. So there are estimates that say that there are 200 billion worth of saving that is possible because of these automations and insights that we are coming up with. We are also seeing a 40% increase in productivity. So these are two main ones, at cost saving and increased productivity. These are two places where GenAI is becoming increasingly useful. Okay, the place I'll jump on to where it's not working, right? The first one is hallucination. I think Usha, you were talking about where the human imperative is important. There are a bunch of problems in AI, and it's not fully clean yet. Hallucination is a big problem because these models are probabilistic, and that probability choice, it may choose something that it It may sound very confident, but it's actually factually incorrect. This is where a human is required to critically think and decide, okay, is the AI right here? Is it giving the right information? Can I really rely on it? That's something where a human is required, and hallucination is a known problem. It's reduced significantly in the 3 years that these LLMs have been in the world, but it still exists. You will occasionally see them come up with ridiculous answers and very confidently say something is correct, right? So that's the first problem. The second is in bias in training data. Now, the most of the world or most of the training sets that we have in the world are English speaking or very Western focused, and it also tends to capture dynamics of a certain population segment. So most of these models have inherent biases, and we know this. We know that certain populations will be ignored, or data sets might be misled. Something as simple as male female, right? They might be inherent biases. Most models today take care of these biases. We penalize models for making some choices. Or maybe we can reward models for making certain choices. So all of those techniques exist, but there will always be bias because the training data is limited in the world. When I say limited, I mean the internet data is limited, right? And I speak from an India perspective, where we have a very diverse population and not a lot of it is documented, right? That is digitized or documented, and that training hasn't been fully captured in these models that are out there. So there will be bias, and as practitioners or people who use AI, we need to be aware of these biases. The third thing is around privacy and security. I touched upon this because everything is digitized. A lot of your patient records are also floating around, and that leads to risks of these being exploited. Like today, and there have been times where you could practically ask for an address of a specific person, and an LLM will respond, okay, based on records it has seen on the internet. So those risks exist. So privacy and security risks are the third where it's not working. The last one is human in the loop imperative. Today, the general consensus is that GenAI can assist, but they cannot replace human judgment, especially in healthcare. And there are no solutions, at least broadly, there's a consensus that healthcare decisions or any critical life-changing decisions cannot be made automatically with AI models. So that's where these are the 4 places where GenAI models have limitations and where things won't work. Yeah, this is where GenAI is not working. I'll pause here again. Let's see if there are any questions. Hopefully that answers your question, Usha. Okay, there are no more questions. Okay, I'll move on to possibly the last slide of this. I want to touch upon what I am seeing as a future landscape, and this is a mix of where I'm seeing more investments happening in healthcare, and what you're in some ways you're already seeing this in a daily life also, right? The first one is around virtual reality and GenAI. We are already seeing tools available for medical practitioners where you can do simulations with AI generated patient scenarios. Today, if you're a doctor who is going through training, you need a real patient, right, who has a specific condition, and you have to go through a session with a senior doctor to diagnose that patient. You could go through that same thing in VR today. You can even simulate, basically walk through or walk through the human body and see where the issue is. All of that is possible today, and it's only going to become more and more common, where Gen AI is being used to train future doctors. And those doctors could have gone through many different scenarios, which would not have been possible if they were actually going through a traditional apprenticeship. Okay, it's not a full replacement of an apprenticeship, but it allows them, or it exposes them to multiple simulations in a very short period of time. So that's one thing that is probably going to happen very soon. VR as a technology is not fully accessible; it's very expensive, but it's only going to become cheaper, and Gen AI will get more and more plugged into this. The second one is around wearables. I think wearables is something that most of us have become familiar with, right? I'm assuming most of us now have smart watches or some kind of a smart device, which can do real-time health monitoring. And these devices come with embedded AI models, right? Apple Watch, for example, can detect potential seizure within 5 minutes. And for a watch to do that was not something easy, at least from an engineering and a technology standpoint a few years ago, but it's possible today. And wearables will only become more smarter. You'll have more wearables but with more smarter AI models embedded there. It may not, it's in everyday population, you might see little benefit, but in, let's say, high risk individuals, for example, seniors, or even children like infants who are probably at very high risk, mortality risks, wearable devices are an extremely powerful tool. I'll give you an example. Maybe in 2018, something as simple as fall risk. People over the age of 70, 75, they are always at a risk of falling. That event is critical for them. If they fall, they are not able to move, they are not able to reach out for help. So having a device that can detect and broadcast that this person needs help is an extremely effective tool. It literally saves lives, and this is very useful for many in the Western world who live very isolated lives, right? So that's one thing where wearables are very effective, and these wearables will become more smarter, given that Gen AI is becoming more powerful now. And the last one, which I feel is going to be the future, it's not there yet, is robotics. Now, unlike you and me, we have many senses, right? We can touch, we can hear, we can smell, you can taste. Today, only language has been modeled, or the algorithms for language has been understood. Hearing, sight, touch, smell, these things are still things that have to be combined and understood, which is what you need for robotics to live in the real world. Everything is so far digital, right? So robotics is probably going to be the future, where you'll probably see more surgical assistants, care robots that work with you, understand you. They can interpret the real world in a much more complex way. So that is still work in progress. There are some early breakthroughs, but not enough to be useful immediately. So these are three places which I think where I think Gen AI or AI in general will become more involved. That kind of unlocks a couple of things, right? Like you'll have digital health avatars, you can have virtual doctors for basic consultations, like the early triaging. Instead of you talking to a nurse, you can talk to an AI and it'll figure out, okay, you probably have something basic, here's what I recommend. Or if you have something complex, it'll connect you to a correct expert and a human expert, and they diagnose you. That is one thing that might become more common. The second one, I think this is already happening, which is real-time clinical decision support. Most doctors have some devices which has kind of a AI embedded. It can analyze the conversation, look at patient records. It can provide insights to the physician to help them diagnose. So this is going to become more common. The third one is the more exciting one, at least for me. If you look at science today, science has zones, right? And even in healthcare, if you are a cardiac or a heart specialist, you know a lot about the heart, but you may have some idea about other parts of the human body, but not as deeply, right? And same thing with the brain, neuroscience. There are many different scientific areas where one person can only be an expert for the lifetime that they have, but an AI can live forever, right? It can look at multi-dimensional aspects. It could combine different insights from different places and come up with something new, right? That automated research is something that's increasingly becoming real. People are looking at research papers from across the world, coming up with new insights, even drug discovery, right? People who have seen a combination of molecules that work for a specific disease, working for another disease as well. So these insights, these combination of insights that learning from these insights is something that's going to become more common because of GenAI. So these are three things that I feel you will start seeing more of in the future. All right, I'll pause here. We can take more questions. We have like 2 minutes, I believe. Oh, 5 minutes.
In case there are no questions, then we can close the session, I guess.
Okay.
Thank you so much, Akbar, for taking out time and taking this session for our faculty members. And it was insightful as usual, and especially with all the examples that you gave. So I'm sure they gained a lot of insights from this session. So thank you so much, and we hope to have you back for further sessions. And all the faculty members, see you tomorrow at 6 o'clock. So thank you so much. Let's call it a day for today. Thank you so much.